Hey everyone, welcome to This Explainer. All right, let's just dive right into it. If you're a developer, a systems architect, or a site reliability engineer, you've definitely played around with AI chat interfaces by now. But as we all know, playing around and actually building for production are two completely different beasts, especially when you've got that lurking back of the mind fear of an AI hallucinating in your production environment at 3 in the morning. Today, we're moving way beyond simple chat prompts. We're looking at exactly what it takes to build production-ready AI applications, where predictable behavior isn't just a nice to have, it is an absolute strict requirement. And honestly, that brings us to the massive elephant in the room. How do you turn an inherently unpredictable AI into a reliable software service? You see, there's this persistent myth floating around the industry right now that AI is just this magical, unpredictable text generator. Like it's a black box where you just cross your fingers, throw a prompt over the fence, and hope the output makes sense. But here's the thing. If you treat it like magic, you can't engineer it. So we're going to shatter that myth today and look at the actual, concrete controls we have at our disposal. Here is our roadmap for today. First, we'll go from experimentation to enforceable contracts. Second, the AI calibration bench. Third, tuning AI sampling parameters. Fourth, setting strict operating boundaries. Fifth, enforcing structured JSON outputs. And finally, number 6, the reliable production pipeline. Let's get to it. Section 1. Experimentation to enforceable contracts. Okay, to really shift our mindset and, frankly, our code from just managing chaotic probabilities to defining strictly typed contracts, we have to internalize this one core thesis. Ready? Sampling shapes what the model may say, but a schema constrains how the answer must arrive. This is our mantra. Think of it like a giant puzzle. We use parameters to gently guide the AI's thoughts, but we use code to build a rigid, inescapable box that those thoughts absolutely have to fit into before they ever reach our backend systems. Section 2. The AI calibration bench. Now, before you write a single line of application code, I want you to think of Google AI Studio as your calibration bench. You really have to use a controlled environment like this before any of your ideas become an actual service. It's basically a rapid 4-step prototyping lifecycle. First up, you frame. This is where you define the role, the task, and your success criteria. Second, you tune, testing out your model choice and tweaking those sampling parameters. Third, you constrain. This means enabling structured output and specifying your exact contract. And finally, you export, taking that finely tuned setup right into your code and adding your parsing and tests. The absolutely crucial takeaway here: you've got to treat these settings, prompts, and schemas as versioned engineering artifacts. Seriously, they are just as critical to your infrastructure as your source code. Section 3. Tuning AI sampling parameters. So as we start turning the dials here, you have to remember something fundamental. Parameters control variation, they don't control the truth. Calibration changes the AI's behavior, sure, but it absolutely does not verify facts or business rules. Let's look at the most famous dial of them all, temperature. Temperature basically reshapes the distribution of likely words or tokens that the model is going to choose. A really low temperature, like 0.0 to 0.2, concentrates that probability around the most likely tokens. It is absolutely perfect for things like audits, JSON extraction, and code repeatability. On the flip side, a higher temperature, pushing up toward 1.0, increases variety. It's awesome for creative ideation, but it totally invites output drift and inconsistency. For the enterprise SRE audit exercise we're focusing on today, setting a baseline temperature of 0.1 is exactly where we want to start. Now, to control that variation before the model even makes a selection, we use top P and top K. I like to think of top P as a dynamic probability net. If you set it to 0.95, it keeps the smallest set of tokens whose cumulative probability reaches 95%. So it dynamically includes the likely tokens while completely filtering out the weird long-tail outliers. Top K, on the other hand, is more like a strict bouncer at a club. Set it to 20, and it only lets the top 20 highest probability candidates in the door, period. As a practical rule of thumb, only ever adjust one of these variables at a time and always compare your outputs against the exact same prompts so you know what's actually working. Section 4. Setting strict operating boundaries. All right, now we need to set our behavioral guardrails. Imagine our enterprise site reliability engineer scenario. We explicitly define the role. We assign a very specific task, analyze a log, and create a remediation payload. Then we add hard constraints. Use only supported evidence and absolutely no conversational prose outside the JSON. None of that, sure, here's your answer fluff. We also define quality standards, demanding a highly precise root cause. Setting up this instruction guides the model's intent beautifully, long before our rigid application code even takes over. Section 5. Enforcing structured JSON outputs. Okay, this is the really fun part. This is where we take unstructured probabilistic text and turn it into a strictly typed interface using Node.js and the official Google GenAI SDK. In our Node.js implementation, we define an exact response contract. We specify the response format as application/JSON, and then we meticulously lay out our properties. A timestamp string, an affected component string. But look really closely at severity. Notice we don't just ask for a string. We use an enumeration, restricting the model to only choose low, medium, high, or critical. Because, let's be real, you absolutely do not want your AI hallucinating a severity level called kin to bad during a massive all-hands-on-deck server outage. We also explicitly pass an array of required fields, demanding that all 5 properties be present every single time, no exceptions. So, what does this specific code actually achieve for us? Well, it provides some incredibly powerful contract guarantees. First off, you're getting a standard object, not a rambling paragraph of free text. You get known enumerable severity values. You guarantee all 5 fields are present. Basically, you dramatically reduce structural errors because you are literally forcing the model to generate machine-readable JSON that perfectly matches the exact shape of the data your backend systems expect. Section 6. The reliable production pipeline. Now, our job as engineers isn't over just because we successfully generated some beautifully structured JSON. I need you to burn this phrase into your memory. Valid JSON is an interface milestone. It is not an authorization decision. Let me say that again. Just because the AI output a beautifully formatted JSON payload saying it's going to restart a worker node database pool, that does not mean it is actually safe or authorized to do so. The schema enforces the structure, but it does absolutely nothing to prove those values are actually accurate or safe. And this is exactly why your application validation still completely governs acceptance. You absolutely must build domain validation checks right on top of your schema enforcement before the AI is allowed to actually restart a production database. Before execution, your code needs to verify that the timestamp format and source integrity are real. It has to ping your actual database to ensure the affected component exists in your inventory. You have to verify that the suggested remediation step is actually allowed by company policy. And perhaps most importantly, you need to check if a human approval threshold needs to be met before taking any action. So, bringing it all together, true production reliability requires all 3 of the core controls we mapped out today. First, you calibrate, ensuring your sampling settings like temperature and top P perfectly match your workload's tolerance for variation. Then, you instruct, using strong system instructions to define the exact role and operating boundaries. And finally, you enforce, utilizing strict JSON schemas, parsing, and domain validation to aggressively protect your application interfaces. Which brings us to the ultimate takeaway equation. A reliable pipeline equals repeatable behavior from tuning, plus clear intent from instructions, plus typed output from schema enforcement, plus strict domain validation in your business logic. Just look at that stack. We have come a massive way from just crossing our fingers and hoping a chatbot returns something useful. We have built an incredible, highly structured system today. But as we wrap up this explainer, I want to leave you with one final, slightly provocative thought. Your AI pipeline is now strictly structured, pumping out perfectly formatted, actionable JSON payloads in a matter of milliseconds. But are your human safety checks and operational policies actually ready to handle the sheer speed and volume of automated JSON? Because getting the AI to behave, that was just the first step. Integrating it safely into your human workflow, now that is the next great engineering challenge. Thanks so much for joining me for this explainer. I really hope you found it illuminating. See you next time.